Alright, number 1. So I'm just going to do the practice test instead of the math around the room because there were some problems with the papers and stuff being written on them. Anyways, 16 times 2 to the negative 3 power. That's going to be 16, and since this exponent is negative, it's going to turn into a fraction. So you drop it underneath the fraction bar. So this is 16 times 1 over 8 now. Notice whenever you drop a negative exponent underneath the fraction, it becomes positive. Make 16 into a fraction by putting it over 1. 16 times 1 is 16. 1 times 8 is 8. And 16 divided by 8 is 2. For this one, if the exponent's negative, you drop it. That's 1 over 8 to the first power, which is just 1 over 8. This would be 1 over 12 to the negative 2 power, or to the 2 power. And 12 to the second power is 144. And since the exponent's already negative, you're going to move it back up. So this becomes 3 to the second power, which is just 9. Equivalent to 1. This is equivalent to 1. This is not, because this would just flip upside down to be 3 squared over 2 squared. This one is equal to 1, because 2 to the 0 power is 1, and 1 divided by 1 is 1. This one is not equal to 1 over here, because this is a negative 1 times 4 to the 0 power. Anything to the 0 power is 1, so negative 1 times 1 is negative 1. Okay. For number 4, to write a reasonable equation, this one's exponential, so this is y equals some number to the x power. To find out what number it is, you just look where x is 1, because anything to the first power is itself. Follow 1 all the way up here, and you'll see that it crosses at 2, so therefore it's 2 to the x power. This one you're going to follow mx plus b. So y equals, let's do your slope first. Your slope is going to be rise 2 over 1. So that's a 2 over 1 slope, x. And then your y-intercept is negative 1, negative 2, negative 3, negative 4. So therefore this equation is y equals 2x minus 4. For this one, again, slope, this is down 1 over 1. So y equals down 1 over 1. Since you're going down, it's negative. It crosses the y-axis at negative 2, so you put minus 2. So y equals negative x minus 2. Just keeping in mind about math around the room, what we're going to do for it. We are going to instead do the math around the room answers before we do our test tomorrow. So we'll still answer those questions. Okay, so number 5. Where are they equal to each other? They're equal in this part and this part. And it's asking you for values of x, so you just go straight down to your x-axis. Right here, that's negative 2. And go up to your x-axis, which is 3. So x equals negative 2 and 3. For this one, you need to use the formula. The amount is equal to the principal times 1 plus the interest rate to the t power. The principal here is $400. 1 plus r, you need to change 8%. 8% when you move the decimal to the left 2 places is 0.08. So 0.08 to the second power. And this is 400 times 1 plus 0.08 to the 5th power, because it says after 2 years and 5 years. Answer to number 7 is going to be 7%. This says that there are 93% left over. So if you start with 100% and 93% is left over, that means that there was a 7% decay. Next problem. Okay. So right here, 8 times itself twice is 64, so that means there's one solution. You can't ever get a negative, so it is no solution. In this case, 7 to the second power is 49, so that's 49 to the x equals 49 to the x. And since they're the same exact equation, that's infinite. And when you raise 3 to the negative 2 power, you get a fraction, so therefore there is a solution. For this one, you're going to change this. 3 to the third power is 27, but since it's a fraction, you want a negative exponent. After this, once you have the bases the same, you take the exponents and set them equal to each other, like we did down here. Subtract 1 from both sides to get 2x equals negative 4, and divide both sides by 2 to get x equals negative 2. Therefore, the solution is correct. Next one. That was the cat. Alright, this one is negative 2 to the x power. This one over here is y equals 10. So here are the graphs. This is the graph of y equals 10, and this is the graph of y equals negative 2 to the x power. They want to know, choose the correct solution. So the solution is supposed to be where they're equal. And since they never cross, that means they are never equal, no solution. The explicit formula is going to be over here. That's a sub 1 times r to the n minus 1 power. And the recursive is a sub n equals a sub n minus 1 times r, with a sub 1 equal to blank. So the first term is 4. Our pattern is going to be times 2. So this is a sub n equals 4 times 2 to the n minus 1. Recursive is a sub n equals a sub n minus 1 times 2, because that's our pattern. And we need to write where we start, a sub 1 equals 4. Explicit, again, you start off with your first number. So your first number is a sub 1. And then our pattern is divide by 3. However, we don't say divide, we say multiply. So we're going to take any number and divide it by the number before it. 2 divided by 6. So 2 divided by 6, if you reduce top and bottom, this becomes 1/3. So it's going to be 54 is your first term times 1/3 to the n minus 1 power. And the recursive is still the same kind of thing. A sub n equals a sub n minus 1 times 1/3 with a sub 1 equal to 54. Next problem. Where did it go? Hello? There it is. Alright, find the correct range. So we need to plug these numbers into x. So this is 3 times 1/4 to the negative 2 power, 3 times 1/4 to the 0 power, and 3 times 1/4 to the second power. So when the exponent's negative, usually you drop it like it's hot, but because it's already dropped, you need to bring it back up. So this is now 3 times 4 to the positive 2 power. Anything to the 0 power is 1, so this is 3 times 1. And since this is 1/4 squared, that means you're multiplying by itself. 1/4 times 1/4 is 1/16. So this is 3 times 1/16. So your final answers are going to be 3 times 16, which is 48. 3 times 1 is 3. And 3 times 1/16 is 3/16. Next, exponential function. This is not exponential. This one is exponential because there's the percent in the problem. Percent's the giveaway. This is not exponential. D is exponential because it uses the words doubling. Next problem. Which function represents the graph? So look at the graph. Notice that it is going up. That means it's growth. This is a decay function because 2/3 is less than 1. The top number is smaller than the bigger number, bottom number. Mice decrease, that's not growing. If you put this as a fraction 2 over 1, 2 is bigger than 1, so this is growth. And when plants die, that means you're getting smaller. So the answer is C. This one doesn't really show up on the test, but by a graph, if you look at the graph and the graph goes up, meaning the graph is doing this, that's growth. And if the graph is going down, that's decay. And then by an equation, if b is bigger than 1, it's growth, and if b is less than 1, it is decay. You be quiet. So for this one, if the exponent's negative, you move it. 3 has a negative exponent, so you move it to the bottom, make it positive. Anything to the 0 power is 1, so you put a 1. b to the 8th is positive, so it stays. And c to the negative 2 is negative, so it moves up. If it's negative, that doesn't tell you where it ends. That just tells you whether or not it needs to move. So 1 times anything is itself, so this is b to the 8th times c squared. And 3 to the 2nd power is 9. That is your final answer. Make sure you simplify. Next problem. Right here, this is 2 to the x minus 3, and you need to rewrite the second equation right here as 2 to the 3rd power. So that's 2 times 2 times 2. Now that the bases are equal, you're going to set the exponents equal to each other. X minus 3 is equal to 3. Then add 3 to both sides to get x equals 6. 18. Function given the domain. So again, you need to plug these all in. So this is 25 times 4 to the negative 2. 25 times 4 to the negative 1. 25 times 4 to the 0. 25 times 4 to the 1. And 25 times 4 squared. When the exponent's negative, you drop it. So this is 25 times 1 over 4 squared. So 25 times 1 is 25. And 4 squared is 16. So that's your first range value. Again, right here, the exponent's negative, so it drops. This is 25 times 1 over 4. 25 times 1 is 25, so that's 25 over 4. Anything to the 0 power is 1, so that's 25 times 1 for 25. 4 to the first power is 4, and 25 times 4 is 100. And then 25 times 4 squared is 16, and 25 times 16 is 400. So that is your range. You'll notice that your range is increasing. Next, you borrow money, $7,000 times 1 plus 0.025. Remember to move the decimal to the left 2 places. And then raise to the power of 3. Plug that all into your calculator. 7,000 times 1 plus 0.025 raised to the 3rd power. And you end up with $7,538.23. Okay, next problem. So 3 to the x plus 4. Since this is positive, that means that you are going up 4. You guys only know up and down. If you see left and right, right away you know it's wrong, because you guys don't know how to do that yet. Right here, this pattern is going to be a plus 3. So you're going to say that it is linear, because there is a constant difference. And write the function rule. So this is y equals, our common difference is 3, so it's 3x. And when you work your way backwards, for 3, 2, 1, that should be 0. 12, 9, 6, 3, that's 0. Since the number when x is 0 is 0, this is just your final answer for the equation. Okay, and the very last problem, number 22. For number 22, we got two equations. We're going to make this one, instead of 0.5, we're going to write 1/2 to the x power. And this is going to be 4. You should always use -2, -1, 0, 1, 2. The test will give you values. -2, -1, 0, 1, 2. So this is 1/2 to the -2 power. Since the exponent's negative, it turns from a fraction to a whole number. So this is actually 2 squared, which is 4. 1/2 to the -1 power. Again, you just flip it. That's 2 to the first power, which is 2. Anything to the 0 power is 1. Anything to the first power is itself. And 1/2 squared is 1/2 times 1/2, which comes out to 1/4. This says y equals 4. This does not say 4 to the x. This does not say 4 plus x. This does not say 4 minus x. It just says 4. So y is equal to 4 every single time. So when you do your graph, here's our graph. Let's make some points. -2, 4. -2, 4, there's a point. -1, 2. There's a point. 0, 1. There's a point. 1, 1/2. And 1, 1/4. So really what's happening with this function is you got a curve going on. There you go. For the next function, -2, 4 is right here. -1, 4, 0, 4, 1, 4, 2, 4. Notice how they all form just a straight line. So there's that. And we want to find out where they cross. They cross right here at x equals -2. Good luck.